Welcome back. Time for some taking of some square roots. Whoa. So quadratics are hard to solve sometimes, not always. Sometimes you just have the quadratic term, the x squared, and you don't have an x. So if you look at number 9, for example, we'll get there in a minute, but number 9, actually we'll skip it, but number 9 has a b squared and it also has a b. So if I take the square root of the whole thing, then I'd end up with the square root of that, which will usually cancel out. But then you still have a b that's under a square root, and that's a problem. But if you don't have both of them, like number 6, we can just take the square root of both sides. Zoom in on that activity. So we take the square root of both sides. Remember, with a quadratic, the fundamental theorem of algebra says we're going to have two answers. Where do they come from? Because you have plus or minus the square root. Fix this. The square root of 12. Okay, and why is that true? Let's look at 16 for or number 5 as an example. If you take 4 and you square it, you get 16, right? But if you take negative 4 and you square it, you still get 16. There's two answers. It doesn't matter whether this number is positive or negative because you're squaring it. So the same thing's true over here. Square root of 12, you have a positive answer and a negative answer. And if you take the square root of that in a calculator, it's going to give you a decimal, a very long decimal, because there's something irrational going on under here. But we can simplify that saying plus or minus the square root of, what's 12? 12 is just 4 times 3. It has a factor that's a perfect square. And so we can then take the square root of that perfect square, plus or minus. What's the square root of 4? 2. It's not under a square root anymore. It is 2. The square root of 4 and 2 are the same thing. 2 is just much more simple to understand. If they tell you at McDonald's that the cost is going to be the square root of $4, I know half of y'all are going to give them $4 because you're just freaked out by it. It's just 2. But the square root of 3 is irrational, so we're going to leave it under the square root and then just say, hey, that's my answer. What is 2 square root of 3? Square root of 12. See that 2 square root of 3 is the same number, 3.464. But by not writing the decimal, we're not going to compromise the accuracy of this number. We're not going to say 3.5 because it's not really quite 3.5. All right, number 8 real quick. Again, we're going to follow the order of operations if we can. And the way you tell if you can do that is by looking for, is there a quadratic term and a linear term? Is there a k squared and a k? No, there's just a k squared. So we are ready to just do some inverse operations. We get 7k squared is equal to 133. That number is not going to divide by 7, is it? Nope. So we get k squared is equal to 133 over 7. Yuck. If you do 133 divided by 7, you're like, hey, I'm not that great at math. It divides evenly to 19. K squared equals 19. I would not have just been like, oh yeah, obviously it's 19. Clearly, I didn't know that until I took the square root because I ain't thinking about it. Ooh, Christmas colors. So we got green going on here. And so now we're ready to square root both sides. Whee! Because we want the square and the square root to cancel out. They're inverses. So we have k equals plus or minus the square root of 19. And we're not even going to do anything with that because 19 doesn't divide by any perfect squares. It's a prime number. So square root of 19, look how yucky it is. Ugh. So we're just going to leave it alone. It's between 4 and 5. All right, we'll pick it back up on, we're going to skip down to number 15 when we come back.